Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Continuing with topic 3, we're going to be generating equivalent expressions, and that you can identify and then write them as well. So this big word, generate, right? That's essentially that you could, that's the identify, right? You can see, and the write, right? That you could create them with by writing them out. Equivalent is a fancy word for equal, right? And an expression is a number sentence with no equal sign. Okay? All right. So if we define equivalent expressions here, equivalent expressions have the same value regardless of the value that is substituted for the same variable in the expressions. So what we can do here is we can actually use some different ideas to write equivalent expressions for this particular expression right here. So we could use, I'm going to start with the distributive property here, right? We could distribute this 3 across. 3 times 4x would give me 12x. 3 times 1 would give me 3. Right? These expressions are worth the same. So we have this expression right here, 2x plus 4. I could use the commutative property to rewrite this. It's 4 plus 2x. And I could check that by saying, well, what if x equals 1? 2 times 1 plus 4. And we're going to see a 4 plus, oops, we'll make that our 2. 2 times 1. We'll see if these are equal. So 2 times 1 is 2, plus 4 is 6. 2 times 1 is 2, plus 4 is 6. Those are still equal. Similarly, I could take this 2x plus 4, and I could kind of factor out, I could work backwards here by saying, what is a common factor of 2 and 4? Well, 2 is a common factor of 2 and 4. And so 2 times something would give me 2x, that would be x. And 2 times 2 would get me 4. 2 times 2 would get me 4. And you can kind of do the same thing. All right, well, what if down here again, what if x is 1? Well, 2 times 1 plus 4, or 2 times 1 plus 2. So 2 times 1 is 2, plus 4 is 6. 2 plus 1 is 3, times 2 is 6. Those are still equal. Right now, if you have a question, I want you to stop the video, come and see me. Okay. We're going to write an expression here that is equivalent to 3y minus 9. And we're going to do that using the distributive property like we just showed in A. Right? So first we're going to think of common factors of 3 and 9. Right? That would be 3. So the first step here would be to separate it out. 3 times y. And then 9 is 3 times 3. And so because both of these pieces have a 3, it becomes 3 times y minus 3. Okay. What I would like you to do, again, if you have questions, come and see me right now. If not, pause the video and see if you can determine if any of these three expressions in C are equivalent. Notice in this third one, I can use the distributive property to say that 5 times 2y is 10y, and 5 times 1 is 5. And so that right there is equivalent to this first one. We can see that. I can also check that by taking this first one and sort of finding the greatest common factor of these two numbers, right? The greatest common factor of 10 and 5 is 5. 5 times 1. And then over here, if I take a 5 out, if I divide this 10 by 5, I end up with 2y left over. And so it would be 5 times 2y plus 1. What a lot of students are tempted to do is to say that 10y plus 5 is equal to 15y. And I want to let you know that that's not true because this 5 does not have a y associated with it. Right? Both of the pieces would have to have a y in there for you to be able to do that. Okay. So we're going to take these two expressions, 6 times n plus 3 minus 4, and 6n plus 14, and we're going to see if they're equivalent. And so what we're going to do first is we're going to take this expression, and we're going to sort of combine all the like terms. We're going to distribute everything out, and we're going to simplify it down. And then once we do that, we're going to see if it's equivalent to 6n plus 14. So if you'd like to pause the video and try it, you can. If you'd like to follow along, that's okay too. So the first thing we need to do is distribute this 6 out, right? So that it would be 6 times n plus 6 times 3, and then we'd still have our minus 4. So this would end up being 6n plus 18 minus 4. And then because both of these pieces don't have a variable, we can simplify that a little bit more into 6n minus 14. And it looks like they might be equivalent. We could also check that by substituting in, right? We could substitute 3 in for n. So I'm going to start over here this time, right? Again, just like in the 3-5 video, excuse me, you're going to substitute in the 3 wherever you see an n, and then you're going to solve. So 6 times 3 is 18, and 18 plus 14 is 32. Right over here. 6 times 3 plus 3 minus 4. All I did here was put the 3 in where I had an n. So 3 plus 3 is 6. 6 times 6 is 36. And 36 minus 4 is 32. And it does appear that those are equivalent. Right? You pause and try this last one. So in red, you can see where I simplified the expressions. And then in blue, you can see where I checked if x was 1, were they equivalent. So in red, you'll notice that I distributed it out. 2 times x is 2x. 2 times 3 is 6. And then I simplified down a little bit. Minus 6 plus 1 would be minus 5. So this expression is worth 2x minus 5, which is not the same as 2x plus 6. Just to be safe, I checked to see what if x was 1. So I plugged 1 in. 2 times 1 was 2, plus 6 gives me 8. And then over here, where my x was, I plugged in 1. So now I have 1 minus 3, which gives me negative 2. 2 times negative 2 is negative 4. Negative 4 plus a positive 1 would give me negative 3. Again, if you had questions here, please come and see me. Otherwise, log on to Complete 3.6 and have a great day.